My name is Paulo Arruda. I'm the creator, founder of FaaStRuby, and we're here today to talk about building a FaaS platform with Redis. The idea of the talk is just to walk you guys through um, how to design a simple FaaS architecture with Redis. There's nothing too crazy here. But before that, I just want to tell you what FaaStRuby is and give you a quick demo of the platform. So first, quick question. Are you guys familiar with the concept of serverless? Everybody talks about it now, right? It's kind of the new cool thing. So they have multiple definitions to that, and the way I see it is basically abstracting away servers from the development team. So every time if you talk about instances, containers, Kubernetes, Docker, to me, if that's in the conversation, there's no serverless going on. Developers should just write code and not worry about any of that stuff. I also don't think that the concept is tied to how you pay for it. Like some people put it like, to be serverless, you only pay, for what you use, and this concept is, I don't know, I don't really subscribe to that. Obviously, you should pay for what you use, but that doesn't mean that meter billing is the only way of doing this. The next question is, are you guys familiar with Ruby? Yeah. What about Crystal? Yeah. Wow. Yeah, that's more than I thought. So for those who don't know, Crystal is just a language that it was inspired by Ruby. So it has a similar syntax, and it's statically typed and it's compiled. So it's really, their slogan is fast as C and slick as Ruby. So pretty cool. You guys should check it out if you haven't seen it yet. So what is FaaStRuby? FaaStRuby is a serverless platform for Ruby and Crystal developers. Um, Basically, why did I choose Ruby? Well, I think the obvious answer is that because I'm a Ruby developer and that's the language I love. But also, I stumbled upon a petition on GitHub, if I'm not mistaken. I don't know if you guys have seen it, but it was "We Want Serverless Ruby." Have you seen that one? Yeah. So when I saw it back in August, they had like 1,200 signatures. I was like, well, okay. So why is it that Amazon is not considering Ruby? Turns out that they did in November. But anyways, that inspired me to excuse me. That inspired me to build a platform just to see if there's a technical problem with Ruby that prevents it from being a great language for serverless, and the answer is no. So I think it was pretty great. Um, I wanted to build something that is focused on the developer experience. So for that, there are two components. Like one is FaaStRuby Local, which is an emulator of the platform, so the users can develop and test their serverless apps locally using functions. Excuse me. And there's the platform component. That's where you push your functions to, your applications to, and you can have it on a cloud that we host, or you can use a self-hosted version. So basically, the workflow for the platform is you develop and test using FaaStRuby Local. You can use any IDE. You're not tied to anything. There's no web IDE or anything like that. You can synchronize the things that you are developing locally with a cloud workspace if you want. That means you can develop in real time against an environment that is like the production environment. And I'm going to show you guys how to do that on the demo. Then you can deploy with one command to a production workspace or any workspace that you want. And workspaces are just groups of functions and static assets that compose an application. And then you run it. And right now, at this moment, the only way to run it is through HTTP requests. And the functions will run in what we call runners. So instead of spinning up a container like Lambda, for example, would do, and having your function always running there for a certain period of time, if it's idle, you kill it. We designed a way to have to create those micro environments in nanoseconds. So the micro environment will come up when you invoke the function, and the function will finish execution. It will exit, and this environment gets wiped, and then the runner is available to pick up the next job. So basically, so that way we don't really have. I mean, we do have code starts, but it's like in 1 or 2 milliseconds versus like 100 milliseconds that you see in other platforms. Let me do a quick demo. So, can you guys see this? Is it too small? No. All right. So this will be familiar to a little bit familiar to Rails developers. So you guys are probably gonna connect with what I'm doing here. So basically, you install the FaaStRuby gem. So gem install FaaStRuby, and there's a little process via the command line to sign up, and then you put your email password. And I do that not just to collect your emails, but because we want to prevent abusers. So it's a real problem. Don't want people putting malware and phishing websites in the platform. So I try to block the bots. So basically, after you have it all installed and set up, you can just start a new project with FaaStRuby, new project. Let's call it my project. So when you run that, it creates the files just like as if you were doing like Rails new, for example. And what it is just a few templates to get you started. Basically, this is the templates is for a web application. But you could start an API, just doing a -- API here, and it would start with an API template. So after that, you just go inside of the folder, and you run FaaStRuby local. It starts up Puma with a little Sinatra application just to serve that for me, and it detects the functions that you have right now. The 2 functions that come with this template are root and catch-all. So what are those? So if you go here to project configuration file, we have the name of the project, a little identifier just so you don't have to come up with unique names, because you'll see that this workspace name will become a subdomain when you deploy. And then there's some, like you can set the public folder where you're going to put your static assets. So you set what the name of the folder is, and default it's just public. The folder that will contain your functions, so defaults to functions, and the root path. So I didn't really want to build a framework. Like I wanted this to be like not opinionated at all. So so I didn't want to create routes and all those things. So the only thing I really have to set is a root route, because there's no way around it. You guys will see why. And the catch-all, just to pick up every time that you try to execute a function that is not there. Or load a static file that doesn't exist. So that way you can have a nice dynamic for a response. So every time that happens, it invokes a function called catch-all. So let's visit localhost here. Boom, welcome to FaaStRuby. Can you guys see? Yeah, right. So basically there's a little log here that I'm trying to make it as easy for the human eye as possible, but there's still some improvements probably I could make here. But you can see that there is a request to the function root, and then the data that was passed, and then it responded, and how long it took to respond. It's funny because locally that takes way more than in the platform. This is something I'm still trying to improve, but it's still pretty fast. So let's add well, let me show you the functions here. So the root function, for example. What makes it a function? You need to have 2 files in it. One is a handler.rb, and inside of this handler.rb, you pretty much have whatever Ruby code you want to put in there. You can require gems that you install. You can require files and just normal Ruby. The only thing you need to have is a handler method, and it takes 1 parameter, event, and this event will have like event.body, event.queryparams, event.headers, and event.context. Context is it's how you pass secrets to the platform. I don't think I'll have time to go down that road about the secrets, but you guys can check out on the website FaaStRuby.io. So the other the other thing that makes it a function is the configuration file. So it's a YAML file that has the name of the function, the runtime. Here's Ruby 2.5 because that's what I have on my machine right now. You can put a test command. Right now it comes deactivated, but if you put a spec folder inside of each function and you put a test command here, every time you deploy, the platform will run the test for you, and the deploy won't happen if the tests fail, and you're going to get a feedback with like an output of the test when it fails. You can do more stuff here, like you can choose to run some commands locally on your machine before you deploy, so you would use that to minify or compile assets. You can schedule your function to run periodically. So in the backend, there's just like a cron service that, whatever you put it in here, it will just execute the function for you periodically. So this root function here is really just I created an ERB template rendered. There's just a normal, like you would see on Rails, for example. So you just pass the variables to the template, and then that's what generates this. So let's add a new function to it. To add a new function, all you have to do is create a folder. Let's add a grocery list. So I'm going to add here lists, and I'm going to add a folder called, oh, come on, VS Code. Right, groceries. So to create a function, the only thing you need to do is, in any folder inside of that functions folder, you just have to add a file, and the file has to be named handler. And because it's Ruby that I want right now, handler.rb. When I do that, FaaStRuby local detects that I'm trying to create a Ruby function and initializes it for me, as you guys saw, and creates the configuration file with the function name, everything. So I'm ready to write. So let's make a simple list here. Let's require JSON, and we're going to render JSON. Let's say apples and bananas to JSON. So once you do that, so the URL path will always follow what the directory structure you see here, with the exception of catch-all and root, for the reasons I already explained. So when you go here in your URL and then you go in lists, groceries, you should see you get the JSON response. And then again, you look here at the log, was a request for groceries, reply, and it renders. So, but now when you're developing a web application, you can't really do that with one function. So you're going to want to see, you want to make a request to your root, for example, path, and that function will call other functions to fetch some data or some other information you want to compose the main page, right? And the way you do that using Async Calls. So there are only two helper methods in FaaStRuby. One is render, and the other one is require function. And I'm going to show you how that works. So you can require a function, and it's called lists groceries. And you have to say, I want it to be called groceries. So this will create a constant for me. And then all I have to do, groceries, dot call. So when I do that, I'm actually making an async call to the other function via HTTP. And why is it async? There's this concept called tail latency that every time there's network calls, so it adds more latency to your response. So when you have to do those, what you want to do is make your calls as early as possible in your function, and then here you could do other stuff, waiting for the response. And only when you call the variable groceries.value or groceries itself, if you are doing a puts or something, that's when the execution will block and wait for the result if the result is already not there. So let's pass it to the template. Grocery. And now I'm going to update here the template file. Here, that's just normal ERB. Let's call it like that, and then P, and then here we're gonna print G, close it, and there you go. So when you save it, let's hope that the demo gods will help me. And when you go back to the root function, there you go. So you have apples and bananas being loaded from the other function, and you can verify that by looking at the logs. So there was a request for the root function, and then there was a request for the groceries function, and then a response from the groceries function, and then a response from root. So that was the request response cycle right there. And then you can do other stuff. So look at your public folder. So you can get here on your assets. And let's say I want to put everything to the left. So you save it. It applies. But now, let's say that I want to develop this against the cloud workspace. Now, if the connection allows, you start it with --sync. And when you do that, it will start FaaStRuby local, but it will do initial sync to a cloud workspace. There you see, remember that identifier that I showed you guys? That's where it goes. So basically, it's the name of the project, the environment, and then an identifier to make sure that you get a unique URL. So then you have your cloud workspace, and then when you access it, that's your function there. So let's add another item to the grocery list. If you come here, handler, and let's add here grapes. When you save, you see it deploys automatically. So when I refresh the page, grapes are there. So as you're saving your as you're developing and saving your files, it's constantly syncing with the cloud, including the style sheet. So if you get this guy here, put it back to the center, get uploaded, and then when you refresh the page, there you go. So now let me deactivate now the sync so we don't spend a lot of bandwidth here. I'll show you how to do a Bristol function. So for example, you have, let's say that you're getting a lot of hits on this endpoint. And then you want it to be a little bit faster. So you can just come here and you can convert this function to Crystal by just changing the name to .cr. So again, if you create a folder, add a file, handler.cr, it will initialize a Crystal function for it. Or you can just convert them. So it detects that it's a new Crystal function. And because Crystal is so similar to Ruby, this code is just going to work. So every time you are working with Crystal, because you have to compile on each run, so when you save the file, it will auto-compile for you. So let's just add another one here, Crystal. And you save, and you see, did I save? No. Okay. So see, it compiles pretty fast, and then when you go back to local here and refresh, you see Crystal here. So you can actually develop a web app or an API using multiple languages, and the case here is Ruby and Crystal. So that was it. That was the demo. Now back to building a FaaS platform. So when I started this, I just wanted to make it really simple. It was just a POC, and that's what I'm gonna guide you guys through. So the requirements, like it has to be fast. It has to be scalable, but it's secure. But scalability of Redis and security is out of scope of this presentation. I would need more time for that. But I need to be able to trigger it via HTTP, and I need to support multiple environments. So the idea was simple. I just wanted to make an HTTP server that I would make a request with a client, and then this HTTP server would just run whatever code that I had in Ruby, and then clean itself up after each run. So I would need a little storage to have the function there, and then it would just really just require the file runs it, so and give me the response. So then I thought, well, I need to have a way to push the functions there. So then I created a simple API that you can upload using curl, a package, a zip package that would unpack this file, put it in the storage. So then I was able to deploy a function there. But then it's getting a little more interesting here. Because I wanted to have different support multiple environments, then I call those workspaces. I needed to start storing metadata for the functions and for the workspaces. So then I decided to use Redis because it's blazing fast, and one of the requirements is to be fast, just to store that metadata. And the way I did it, just pretty simple. I just had a little ID that I generated randomly using, sorry, not randomly, but using counters. A name for the workspace, a path on the disk where the workspace would be, and the functions inside of that workspace. And then I created just a simple key on Redis like W, and I namespaced it with W and the workspace name. So then for the function, same thing, created an ID. I named it, put a field for the name, the runtime, the disk path will be the workspace path and the function name, basically. And again, I chose to put the key inside of the workspace name because when you make a request with the subdomain, I grab the workspace name from the subdomain, and I want to just get the function from that subdomain. So that was the fastest way I found to make that request happen. So then I say, okay, so how do I add more replicas to this? So then I added more replicas of the HTTP server and of the API, but then that created a problem. So because that HTTP server only responds to one request at a time, is not multi-threaded, every time I make a request A, it goes to server A and run the code, and B goes to B and runs the code. But then when the C request comes and the A and B are busy, so how will the load balancer decide to which server to send the request to? Because there's no way to predict how long a function will take to run. So that would make the load balancing algorithm a little bit complex. I tried a few different things, and it's solvable, but I just found that using Redis to solve that problem as well would be much simpler. Are you guys familiar with the reliable queue pattern? Have you seen it before? So basically, on Redis, you can just you can use L-push and push some jobs to an input queue, and then you can have the process that is the workers are gonna execute the jobs. They use like a br pop L push to fetch the jobs from this queue, and it's the B in the beginning of the command it means really blocking. So the client will connect to this queue and wait until there's a job there, and it will grab the job, but it will atomically what this command does is to push into another processing queue. So I have to pass another list to put that job in, and then once the task is finished, the client will just run LRAM and remove the job from the processing queue. But if it failed, you can just push it back to the input queue, and then another worker will get it. So that's a pretty standard way of doing queuing with Redis. So then I wanted to decouple the HTTP server from the code execution, so I could have the HTTP server replying to a bunch of different requests, but also have the function runners being able to fetch those jobs and reply as soon as they can, as soon as there's one free. So in this new scenario, all the requests will go to the queue, including the request C. So basically, I had all the runners connected to this input queue, and they would execute the functions and reply as soon as they are available, as soon as they are done executing another function. So that way, the request would be the client makes a request to Nginx. I had to put a proxy in front of it to do load balancer to the HTTP server, and then HTTP server will put a job inside of a Redis queue, and a runner will fetch that job. But when the HTTP server puts the job there, how does it get a response, right? So I also use the queue pattern. So every time the HTTP server puts a job on Redis, it will actually create a random UUID, and it will subscribe to a queue of that name. And then with the payload, telling the runner, hey, run this function, it will pass the function metadata that in this request cycle, I omitted from here, but there is another trip to Redis here to get this the metadata information. And then we will also pass the event properties like body, query, headers, etc. But it will tell the runner, hey, when you're done finishing the function run, just put the response back into this queue that I'm listening to. So that way, the HTTP server gets the response to the client, and that's basically how it works. So just as a recap, we use Redis as the main database. It's funny because I keep telling the Redis folks that they should stop calling it a database and really call it a Swiss Army knife, because you could do a lot of stuff with it. And we use the reliable queue pattern to distribute the execution between runners. That was it. Thank you.
Any questions?
Yeah, maybe I missed this, but so in this,
Just a second.
yeah,
Yes,
So
now I can hear you.
okay, so maybe I missed this, but so in this serverless environment with function as a service, so somehow you've got to tie your functions together, and I'm missing. I didn't see how you were doing that. I mean, one function has to follow another. Basically, you just have one script, and a centralized object waits for these responses.
I'm not sure. Can you try to explain again?
Well, you're going to tie these function calls together. Okay, so you
Right.
may do some parallel processing, but those
Right.
results come back and you may store that. And then you're going to have some order, I mean, obviously, but yet there's no state. Nothing is tying these together in this function as a service.
Right.
Yeah, so are you using what features of Redis are you using with that, or and how much of that is Ruby? I mean,
Yeah. So for that, I'm not really using features like Redis features to store that state. But for this simple architecture that I showed, it obviously doesn't cover that. But in FaaStRuby platform, I was just showing everyone at the beginning. I don't know if you were here to see that, but how you can call functions from within another function. So basically, every time you invoke a function, it's just an HTTP request, and it gives you back a response, right? So the way you would do, you could just do multiple parallel requests. Like say you invoke a function A, and this function A has to go get a grocery list and get a list of pets. So this function A would, in the background, make another invocation for those two functions and grab the response back. And then on my code, I have to do whatever I want to do with that response. And the way it's done on FaaStRuby is just asynchronously. So you fire the requests, but the code execution continues until you really need the return values of those functions. But then it's up to the developer to decide how to handle them. Any more questions?
Is there a reason using Nginx? Could you just have something else, like a piece of Python code running in another container, throw the job into Redis?
So actually, maybe I should have been a little more clear here, but I really put Nginx here just as an example of load balancing, but you could have used HA proxy or whatever you want to use. But it's HTTP server. In the case of the FaaStRuby platform, I actually wrote that in Crystal. So all the parts of the platform that need to be fast were written in Crystal. But that's, are you a Ruby developer?
I've done quite a bit of it.
Yeah, so it's just, this is just like you have a Sinatra and and an Nginx in front of it, basically.
No, I've done that. I'm curious, how did you connect Nginx to Redis? Did you use like the Redis module that comes with Nginx?
No, I did not connect the Nginx to Redis. I connect the HTTP server to Redis. Right, the Nginx is here just to serve as a load balancer.
So using like a Sinatra behind Nginx.
Yes. Yeah.
Okay.
Yeah.
I'm just curious if you've tried connecting Nginx directly to Redis, because there are some modules for that.
Yeah. So I looked into that. I know I can do that with Lua, for example, right? But that's actually something that I'm interested in trying, because that will cut this middleman here. Will make the request response cycle faster.
Yeah, that's a way to simplify architecture. I have not done it. I was curious if somebody has.
Yeah, exactly. Yeah.
Are the runners background job workers only, or are they serving with a server?
So the runners are really Docker containers, and there is like some custom code inside of those. Like there's a process that I call just Redis runner. They are just connected to Redis, waiting for those jobs to come in the queue. And then when that happens, when it picks up a job, it creates this like sandbox, and then execute the code, requires the code and execute inside of the sandbox, and then the sandbox dies, and then the runner the process sends back the response, and then it's just sitting there waiting for the next job to arrive. Yeah.
Thank you.
Hi, thank you for the talk. I haven't used FaaStRuby before, but I have a couple Ruby applications. And I'm just wondering, is there any limitation if I have relational database Ruby code and try to convert to the FaaStRuby just for the sake of performance?
Yeah, so one of the problems with serverless functions in general is it's the call to databases, right? Specifically on FaaStRuby, your functions don't stay running, so you would have to create that connection on every execution, but you shouldn't really do that because there's a big performance penalty. So my solution to that is something that I haven't done in the platform yet, but it's coming. I'll create what I'm calling a database connector. Basically, I'm going to do the connection pooling in a separate instance of that I'll provide to the users, and then all you have to do is send requests. It's like really a database proxy, and you just make requests to this proxy. There will be some security in place, so there's no data leak or something like that, and then this proxy will be so there's still a network call that has to be initiated here, but it will offset the problem a little bit.
Is there any limit on response size? Because you are storing all the responses into Redis, and it could cause an issue, I think, in the
Yeah, so we try to keep the response sizes under 5 megabytes. But that said, nobody's gonna use Ruby for like background processing, image processing, video processing. So the idea for this platform is really it's really for people who are looking for something beyond Rails, for example. If you want to build and you don't want to have to worry about servers and deployment and CI and pipelines or anything like that, you should be able to deploy a distributed app, because when you deploy those apps, each component of those functions goes to this cloud of this cluster, this Docker cluster. They're running everywhere, so you have a distributed application that way. So that's but to answer your question, there could be a problem with the limit of the answer of the responses. Yeah, but we limit that. Yeah. Any more questions? All right, so I just wanted to make a quick announcement. Up to now, only the gem was open source, but I'd like to announce that the whole platform and the whole way how we do the runners and the security behind it, we're in the process of making it open source. So I want this to be available so everyone can look and see and use it. So we're open sourcing the platform. Thank you.